Another topic that I frequently hear, well, why do I need to know this? Many times when I've taught general math or math for elementary school teachers, we talk about three-dimensional solids and their surface area and their volume. And a lot of times say, why do I need to know this kind of stuff. The truth of the matter is there's a lot of applications for just home improvement, a lot of jobs where you have to be able to calculate volumes to do things. Let me just think home improvement for just a moment. I mean, you could, if you're blowing insulation into a wall, you have to have some knowledge of how much insulation you're going to need to put in there. If you're buying mulch, you're going to need some kind of calculation of how many cubic yards of mulch to buy, these kind of things. Maybe you're digging out a decorative pond and you need to know how much dirt you're going to need to fill in around it. There's all kinds of things where you need to figure volume. And I do want to go ahead and caution you a little bit on this. There's a difference. We talk about volume as a cubic measure of length. We also talk about a lot of times capacity. When we mention things like cups, pints, gallons, liters, these kind of things. There's a difference in the two, although they are related. Okay, and the best way I think to illustrate that is by thinking of a brick. Okay, a brick has volume. You can measure it in 3 dimensions. It's a block, so you can calculate the volume. It doesn't have capacity. It might have a little capacity if you fill in the holes in the brick, or if it's a solid brick, it won't have any capacity. Capacity is how much liquid, basically, something can hold. Volume is how much space does it take up. Okay, so I'm working on volume. I'm not worried about liquid kind of containers and these kind of things. The one application I want to show you today that I think will be interesting is pouring concrete. I've done this as a kind of a do-it-yourselfer at home. I've taken on projects like this where I poured my own concrete. You might even wind up in a job where you do this. I mean, that you could do that for a living. And those folks, a lot of times, don't have college degrees. So I get a little touchy when we start saying, oh, why do I have to know this? Well, there's people out there without college degrees who have to know it to get their job done. So what I'd like to do is look at a few different situations where you would have to, if you were going to pour this, or we're going to have to give an estimate on getting it poured or something like that, you'd have to calculate volume. Let's say you're going to pour a sidewalk kind of in an L shape, 12 feet this direction, 15 feet in this direction, and it's a 4-foot sidewalk. And these little gray lines, they put in little breakers in there to allow for expansion. We could calculate the area of this. We don't know how to do the area of a L-shaped thing, but we can break it up into pieces, right? If you'll notice, I put in a little purple line here. We could break it up into a 12 by 4 rectangle, and then a 11, that's 15 minus 4, rectangle, and it has area 92 feet on the top, okay? But what we're really looking at is pouring this thing. Typically, they pour concrete 4 inches deep. This is a prism. Okay, we have a polygon on the base of this thing, and the volume of prisms is pretty easy. It's the area of the base times the height. The only thing I have to be careful about is I have one measure in feet, I have another measure here in inches, and I need to use the same measures throughout. So I would go 92, but then 4 inches is 1/3 of a foot. So that is 92/3 cubic feet, and then concrete is sold by the cubic yard, so I need to do a conversion there. But again, it's multiplying by 1 3 times. 1 yard is 3 feet, 1 yard is 3 feet, 1 yard is 3 feet. So it works out to be a little over 1 cubic yard for that kind of pour. That's basic kind of arithmetic, but that's a useful kind of thing for those kind of projects. Here's one that's a little tougher perhaps. Let's say that you're pouring a ramp up to an outbuilding or something like that, storage building. And it's going to be 4 by 6. It's going to have an increase in steepness of 8 inches. And you're going to pour this in concrete. The thing to kind of remember is you can't just pour this on top of the ground. You have to have 4 inches of base underneath there. So to calculate this volume, again, this is a prism. This is a polygon on the end here, and it goes consistent throughout to the other side. And it's already broken into 2 pieces here, so I can calculate The area of the base is 1/2 base times height. That's the triangle. So that's 1/2, 4, and then 8 inches is 2/3 of a foot. And then it's a 4-inch by 4-foot rectangle. So that's 4 times 1/3. And that works out to be 8/3 square feet. Then the height of the prism in this case is 6 feet. So multiply by 6, that's 16 cubic feet. And again, we can calculate the volume in cubic yards. 1 over 27 cubic yards is, that's the result of saying 3 times 3 times 3 in the denominator. So it works out to be almost 6/10 of a cubic yard. Okay? And I meant to mention this earlier. When you're ordering concrete, you probably want to round up, because once you start working with concrete, you really can't stop and then go back and do it later. So it's probably wise to round up. Typically they carry a little extra on board just in case, but it's probably wise to round up just in case. Let me give you one more shape. I've seen some patios like this, kind of decorative things where you had a circular patio, maybe had a grill set up around the outside of it and some plants and things like that. The one I'm looking at has a radius of 8 feet, or if you want to think of it, a diameter 16 feet across. Again, I'd like to pour this at least 4 inches deep, or I'm thinking 4 inches deep. When you look at it like this, you have to realize, well, this is a cylinder, right? It has a circular base, it has a circular top, it's consistent throughout, and again, it's base times height, area of the base times height, but in this case, the base with a cylinder, the base is always a circle. So it's pi r squared, that's the area of a circle, times the height. So with our calculation here, the radius is 8, square that, pi, and then again the height in terms of feet would be 1/3. So this works out to be 64 pi over 3 cubic feet. The last thing we need to do is that conversion again to cubic yards, because that's the way you order things. And it works out to be about 2.48 cubic yards, which is actually a pretty big pour. Circles take up a lot of space. That's just one example, and we could have gotten into mulch and things like that. But to me, concrete made the most sense because you can pour concrete with minimal waste, and you can also get in situations where you pour very complicated shapes. And you have to be able to adapt your formulas that you know for like boxes and cylinders and things like that to the situation. And I gave you some examples of doing that. Again, I'm going to flash up some summary pages of the things that we talked about and kind of get ready to talk about the stuff in the last segment.